Welcome to the video notes for lesson 10-6. I know it says 11-6 at the top. Cross it out, change it to 10-6 so you're not confused. This is a lesson about comparing functions beginning on page 35 in your notes packet. The learning target: I can compare functions represented in equations, tables, and graphs. Alright, so here we have an example. A portion of the graph of a quadratic function, f of x, is shown. The table shows some values for an exponential function, g of x, and the linear function, k of x, is provided. So they give us the rule, the graph, and the table. For each statement, A through C, so we got three problems here, write either less than, equal to, or greater than, and the line provided. So we're going to be doing some comparison. Alright, question, or the first one, A. The y-coordinate of the y-intercept of f of x is, so the y-intercept of f of x is right here, and the y-coordinate of that is 5. Is blank the y-coordinate of the y-intercept of k of x? Well, when I look at k of x, here's my function rule. Remember, this is the y-intercept, and that means that it's at 5 also. So what does that mean? Well, if they're both 5, they are equal. Okay, that was pretty simple. Question B. So we're going to find f of 4 and compare it to k of negative 12. Now, for the graph, so when we plug 4 in for the input, in other words, we're replacing x with 4, so go to where it's 4. This is not the value we want. We go down and we look at what goes with it. It's the point 4, negative 3. And this is the value that we're going to use for f of 4, negative 3. Now, if you don't like that and you would rather come up with the equation, which you can because you now know and understand vertex form, and our vertex is here at 3, negative 4, you could probably come up with an equation, find it a different way. But the graph is a lot simpler. For k of x, we are actually going to need to substitute this value in. So we've got k of negative 12, and I'm going to substitute that in for x, negative 12 over 2 plus 5. That's all I'm doing is using the rule. Negative 12 divided by 2 is negative 6 plus 5. Negative 6 plus 5 is negative 1. So k of negative 12, when my input is negative 12, the output is negative 1. Alright, so looking at these two values, negative 1 is greater than negative 3. Don't get that mixed up, please. I know. Sometimes it's hard to remember that in the negatives what is happening. Alright, so one more example to do. Question C. The average rate of change, remember that from the last lesson, for f of x from 0 to 3. So I'm going to look at where f of x is 0. Actually, you know what, let me scroll this up just a little bit. We don't want, there we go. We want to be able to see some of the graph and the table, and I think I moved this up a little bit too much. Let's see how that is. That'll work. Let me scooch it just a little bit. Alright, so when I look at f of x and I look at 0, that's here on the graph. And when I look at 3, that's here on the graph. So that's the points 0, 5, and 3, negative 4. When I look at the table, g of x, so going from negative 1 to 3, so here's the point for x equals negative 1, and here's the point for x equals 3. So I'm going from negative 1, 16 to 3, comma 1. So you should see where I got those 4 points from, the 2 for f of x and the 2 for g of x. All right, now I'm going to move this up a little bit so we've got some space to work. Remember, to find average rate of change, you're finding delta y over delta x. Change in y over change in x. here's my y values, and remember you go with, actually you can subtract it any way you want, just find the change. So I'm going to do 5 minus negative 4. The reason why it doesn't matter is because if you switch them around, it did negative 4 minus 5, and then did 3 minus 0. Well, you'll see. And then I'm going to do 0 minus 3. And when I do that, 5 minus negative 4 is like 5 plus 4, and that's 9, over negative 3, which gives you negative 3. So if I switch these around and did negative 4 minus 5, I get negative 9. 3 minus 0 over 3, negative 9 over positive 3 is negative 3. Either way, you're going to get an average rate of change of negative 3. Here, just make sure you're consistent. So I'm going to do change in y over change in x, delta y over delta x. 16 minus 1 over negative 1 minus 3. So 16 minus 1 is 15. Negative 1 minus 3 is negative 4. 15 over negative 4 equals negative 3.75. So this one is greater than. Alright, pretty simple stuff. So you're going to be using some of the skills that you've learned in this unit and in previous units. So over on the next page, you've got some examples with the answers at the bottom. So after you try them, check and see how you did. On the next page after that, page 37, we're going to be doing some other practice. Graph the function f of x equals 1 to the x over 2 minus 4. State the domain and range of the function. Remember to create a table, x and f of x, and then plot your points over here. I'm not going to give you any more tips on this. So you've got the next few pages of practice to do. So if you had any trouble with anything in this video, go back and rewatch it or come and see me for help. Good luck, and we'll see you in math.